So till now we have seen how to build various kind of machine learning models, means classifications model, regressions model, means like that, clustering models. How we'll build, we have till now we have seen everything. But the questions is, after building this model, what we will do? How we will apply these models on real world industry, or in industry, or in some company? How we doing this job? That's the main thing that we have to know. Okay, how will productionize these models? That's the first questions that come into our mind. How will productionize? So let's see it. Let's try to understand these things. When we discuss the various case study, then we will apply it on our real world. Okay, then we'll see. Then you will better see it. Just try to understand how these things are actually happen in our real world industry. Okay, so first thing that we have to do, on our some we have some data sets, detrain. On these data sets we have, using some methods, some machine learning models, we have built some models. Okay, and finding, after finding some performance metrics, we have satisfied, okay, everything is okay, we have satisfied on our models, our models are works well. Build some performance metrics. We have built some performance metrics and satisfied onto it. Okay, and how will finding this performance metrics? By using the simple, the traced data on these models, we have to use this test data. Okay, everything, that's the thing that we have till now we have doing this job, simple thing. So these things are actually work in our own systems, means offline we have to doing it. Okay, offline mode in our box or in our system, we are doing this job. Till now we have doing it. Now the questions it, we have, okay, everything is okay, we have built our map, we have built our models, we have satisfied everything. Now how we'll apply these things on a real world machine learning? So in a real world, what do we have to, how, what actually we need to get the, we have to give the output based on these models. Once users or customers or users will give the query point, we have to take this query point and apply this query point on our model if, and we have to take its output yq. We have to take its output yq, and or yq means in classifications or regressions, or sometimes we will need its probabilistic value, means probability of yq is equals to 1 for a given xq. This kind of probability value means classification, that's the thing that we have to do. Okay, we have to take the input from users, it's that things are given by users, and that thing we have to given to that user, particular users. Okay, that's our systems giving the output or something like that. Okay, that's the simple that we have to do these things through an online mode. These that things we have to do through an online mode, or you can think like in a productions box. In a production box, that's a directly communicate to users to our system. Okay, that's the thing that we have to. Now let's see, there have had so many steps to use it, there are various kind of technique to use this technique. Now let's see how will each one by one, let's try to understand this. First, most of the well-known company like Google, Facebook, like Amazon's, like that well-known company are use this type of technique, means it's the simple technique that are used. If you suppose in your, you are doing, suppose let first thing, you are a startup guys, you are going to start a startup company. Then the simple, you have not so much scientist, you have not so much your computational box power, you have not so much resources. In such scenario, we have to use our own knowledge. For simple, we have to use the Python, we know Python language, we have fewer systems, fewer engineers, and sometimes you have to do all the things in yourselves. Okay, let's see it how we'll doing this job. So first, we have to using the simple sklearn. It's the very popular library in a Python language. When we discuss the case study, step by step, everything in primary, in start to up to end productionizations models, we have everything we have seen in detail. Okay, first thing, using simple the sklearn library. Using simple sklearn library, how we do its job? We have to build on our system using the data sets. Somehow we have collected the data sets. On these data sets, we have to build our model. If we have built a model, if suppose let's it's the these things that it's called, its step is called the model, model persistence. After building these models, we have to store it in our own system, on our own disks. It will be a hard disk or it will be our SSD, like that. It will be hard drive or it will be solid state drive, like that. So this step to after build the models and you have to store these models, these steps are actually called that model persistence. Persistence, sorry, persistence, sorry for that, sorry for it's my bad, persistence, model persistence. These things are actually after storing it, after building it, we have to apply these models on the real world, on our users, user interface. We have to build, suppose in our websites we have built some websites or some applications we have built. On these applications we want to apply these models. Okay, so first thing, from these disks that we have loaded, first thing we have to load it onto our RAM. We have to load these models onto our RAM. So we have, when we will discuss the case study, discuss real world case study in how we using this sklearn library, how we doing this job, simple job. By there are fewer line of code, that simple job that we have to do. Okay, we have to use this simple load this model, load it to our RAM. Okay, from this we have to load our RAM, and using some HTML code or sample MySQL code, like that kind of code we have to apply, and we have to find its output for a given user's input, for a user's input xq, we have to give the output, we have to give the output yq. It will be our website or it will be our some applications, like that, like means this kind of these things are called the, this step is called the productionization. These things are called the productionizations of the models. These things are called the model piece persistence, model slow or store the models, and when we use, we have to load it into our RAM and we have to apply on our interfaces, like that. That's the first step. Some startup guys are a simple step doing that. But sometimes, suppose if you think like a Google, so they are have huge amount of customer. In a second, they are have billions and billions customer who search some queries. And we have to give the low latency output for each customer at that same time. Yeah, how will do the same job for a Google? Let's see. In the second type of production is mainly custom implementations. Mainly the look like a large company. Those who need to build a low latency system. This they are applying these things, simple thing, custom implementations. Okay, so mainly it is used to build a low latency system. These things are used mainly. Custom is mainly to build a like Google, like YouTube, like you can think like Amazon's like that. They are using this type of technique. So there are various few steps. First thing, we have to store all the parameters. Suppose if you think like a logistic regressions. So logistic regressions. So first thing that we have to store, we have to store all the parameters of our models to a file. To a file like means to a some kind of dictionary it will be, or it will be hash tables like that, or simple of our models, of the models to a file. Instead of storing whole the models, we simply stored only the parameters of that corresponding models. Okay, to a file. So if you like it will be very simple if you just took this example. Suppose let's I have already we will taken here the logistic regressions model. We have applied some technique and we have built the logistic regressions, and we will already seen in logistic regressions main parameters are weights. Weights are the main parameters. Only we need these weights. If we somehow we have calculated these weights, then everything is done. Okay, so these are the simple parameters. Only we have to store these weights. We have to store only this weight. If we store this weight some file, then we will know simple for a query point. We have to multiply these weights to our query point, and after we have to apply some functions onto it. Suppose let's it's sigma functions, and we put the output. It is a simple thing. We already know. So simple, we need to store these omega w's weight vectors. If we're doing this simple, then you can simple write this code in C, C++ or Java like that. You can simple like this code, C or C++ or Java, any language, any low latency language you can use to write this code. It's a simple 10 to 15 line codes you can easily write. Just you have to need to know these things. If you know, then you can easily build it. Okay, now if you simple, it is the logistic regressions. If you take, suppose we will apply decision tree. If we apply it in decision tree, what is the things that we have to store? We have to simply the if else conditions. If else conditions are nothing else. We have to store it. So simple, if you write some code using the C, C++ languages, if this code, if you write simple the if else conditions, then you can easily build. Only 1 milliseconds you can give the output. Okay, so suppose if our models mean we have to store these, we have to write these things in some low latency languages. The users give the input query, and we can simple using these models we can easily give the output. It will take some milliseconds, 1 millisecond, like that kind of thing. Instead of using loading whole the model, that this first step is actually doing by the simple startup guys, that there have no so much huge so much demand on internet. Okay, they are using simple load the whole models and onto it, but on a famous company, those who have huge amount of demand in per seconds. So you can think like Google, in a second there have billions of query in a Google. I will give. That's the simple thing that you have to do. Okay, that only these parameters they have to store, and simple using this C and C++ code that give this simple output in a 1 millisecond. Okay, that's the simple thing. Okay, this is one technique custom and implementation. So there have also another technique like in B, suppose like that, instead of using here file system to store all the parameters in file, we have store it in some data structure. We have to store. Suppose let's we have using here the logistic regression. Let's try to understand these things through the logistic regressions. The logistic regressions, we know wi's are the parameters only we need to store. Instead of storing these wi's into a file, if we somehow we have stored these things into some hash tables. In Python, it is a very good data structure. In some hash tables, only two things we have to store here. Only two things we have to store. One is key and another one is value. Okay. And suppose let's in the query point xq, we have some dimensions. Some dimensions, 6 dimensions. Suppose let we have 6 dimensions. 2, 3, 6. 6 dimensions only we have. Suppose it is the sparse vector. Let it is a very sparse vector. Means most of the elements are here 0. Suppose let 0, 0, 1, 5, 0, 0. Most of the 0. Okay. And wi is also it will be the same dimensions to our query points. Suppose let's also w is also same dimension. w1, w2, w3. Here we have to w1, w2, w3, w4, w6, and it is the key value here. Here key 1, 2, 3, 4, 5, 6. So only just see it. Only these 3 and 4 indexes are non-zeros, and everything is zeros. So here we don't need to call here from this. Suppose it is a structures of the hash table. You can think these things as a hash table or dictionary. Hash table or dictionary. Dictionary data structure. Okay, so suppose just see these things. See these things. Here only 1, 3 index and 4 index are non-zeros, and everything is 0. We have not to take. At the end of the day, in logistic relations, we have to calculate it. We have to calculate a W transpose XQ. Means what? W transpose XQ I is equals to 1 to D WI into XQI. XQI. QI means Q1I, Q2I, Q3 like that. It's XQI means here XQ1, it's XQ2, here it is XQ3. Look like this. Here it is XQ6. Here D is equals to what? D is equals to 6 here. So here only we have to multiply these non-zero values. We don't need to compute for these zeros. 0, 0, 0, 0. Only it is not computed in our calculations because it will take us so much time to get the output. Only we need to do. So since we have only these two index has non-zero values, only we call it. Just take this 3R index value, just take it 4 index value and put this 2 weights. Only 2 weights. I don't need to compute else this one. Only we need 5. We need 1 and it multiply into W3 plus we need 5 and we multiplied into W4. That's the simple thing that we have to do. Only these two operations we have to do instead of using this whole operations. We can easily build these low latency systems, and this will be also our YQ. This will be also our YQ. Just see it. That's the simple thing. By using this simple data structure, instead of to load these things into a file, if we just using this simple data structure, you can easily build a low latency system. That's the advantage. That is the advantage of it. Okay. Similarly, here if you take it as a decision tree, if you have used the decision tree or random forest, at the end of the day, what is it? Is then nothing. It is the decision tree or random forest. It is an if else conditions. Means here if you have some conditions, if features 1 less than some threshold value theta 1, if yes or if no. And also here features 2, here have some threshold value theta 2. Here some f3 features value less than some theta 3. These kind of structures we have seen in decision tree or random forest. Okay, means simple. At the end of the day, this is what? This is a simple if else conditions. At the end of the day, it is a simple if else conditions. So simple we have to write a simple low latency if else conditions. if else conditions by simple using the C or C++ or simple Java as you want. Using this low latency used, we have built a function simple. This function, suppose let's say float eval functions. Some we can you can, and it's simply execute, and we will be using this if else conditions, something like that. If else conditions. We have built a some functions, and its IQ will be like that. The simple functions, you just give the xq value, and simple using these functions we can give the output. That's the simple thing that we have to make by using this thing. That's the simple job. Okay, so this is the techniques. Suppose let's in Google there have the huge amount of query in a second. In such situation, what we have to do? So suppose this take these things are called the high throughput. high high through high throughput. If these things happens, mean in a lots of query in a small short time. These things means we have lots of query execute in a short time. If these things happen, that means what? Means there's things in Google, they have huge amount of computational power. Means they are have like that. They are have a various many machines that we apply the same functions. Suppose let's it's the CPU1, CPU1, CPU2, CPU3, like that. There are lots of machines in Google. There have, suppose let's it's have CPU n, lots of machines, and they are have in a millisecond they are have lots of query. In a second they are have a billions of query. What do you have to do? You have to use the load balancer here. These things are called the load balancer. That will balance the load. These things are called the load balancer. Load balancer. Load balancers means what? Suppose let's they are have n machines. They have n machines. So you have taken the all the queries. The load balancers taken all the queries that have taken, and it's distributed equally to the same machines. So it is equally distributed, randomly distributed equally. Suppose you have n machines we have. Suppose let's in Google there have n machines. There have in a second there have lots of billions of query. So they randomly taken this much percentage, randomly sample this much percentage query and send it to this system. Randomly sample this much query and load it, send it to the system 2. Randomly taken this much query and send it to the system 3. Similarly, randomly sampled from this query, from this whole query, they are randomly sampled some query and send it to the system. That's the simple thing that are doing by the load balancer. This simple load balancer technique they have applied to take it. So in Google, there have huge amount of computational power, huge amount of systems. Okay, by simply using the load balancer, they have taken all the query and equally they have distributed it to the edge systems parallelly. Okay, that is the simple thing. That have one technique, and another technique is the computer organizations technique. Let's see it. What is this computer organization? How these things are actually work? So if you have a computer guide students, computer science students, then you have know already very, it will know how these computer organizations actually work. In the computer organizations, they have this type of, they have one CPU, and CPU, they have two type of memories. One type memory is called the CPU cache memory. Cache memory. This memory called the cache memory. cache memory. So in CPU they have a cache memory, and another one they are have a RAM. Another type of memory already we have known, everyone they are have another type of memory that we call RAM. And another type of memory also they are have called hard disks, HDD or SSD. You can think solid state drive. It is today's it is very popular SSD. So these three type of memory have in computer. One is cache memory, one is RAM memory, and it's hard disk. It's very large. Hard disk is now today's laptop or systems. They are have TBs hard disk, 10 TB, 2 TB, 3 TB, TBs in TB. It is very large. It's you can think like a not very large. It's a large means it in GB you have means 4 GB, 8 GB, 16 GB, 32 GB like that. It's very large, but it's very small. Cache memory is in MB. In today's MB, it's very small memory. This is very small, very small. But the latency depends on it. Its latency, cache memory latency is very fast. Actually, if you computer science you already have known, its cache memory latency is very fast. Very means very fast. It's not so much, but first it's fast, little fast. But its latency is very slow. That's the simple thing. Okay. Now, if you think like a logistic regressions, if you think like a logistic regressions. So at the end of the day, we have to need the weights only. We have to need the weights only, and we have to store it some data structures. We have to store it some data structure. Data structures we have to store. Instead of to store these whole data structures that are stored that these WIs, if you store this data structure to a cache memory, if you store this data structure to this cache memory, then to for a query point, it will give them so much fast response. Since if you store these data structures into a hard disk, then it will come to our RAM, then RAM will give this in cache, then cache will take it in operations, then it will give the output. So it's just a time taking matter. Okay, instead of storing it into our hard disk, if you directly store it into our cache memory, then it will give our so much. Means you can think like a 50x to 500x to 1000x faster time it will give. Okay, that's the simple thing that means most of the famous company are doing this simple organization structure. They have and they have applied, and simple these things we can easily write it in using the simple language C or C++ or simple Java. If you apply this simple thing on this language, then you can easily apply it. Okay, this is a simple thing they have applied. So instead of to store this whole data to a hard disk or RAM, you will store it to the direct cache memory, and it will give this output to using this cache memory. It will give the query point using this cache memory. You will make its compute. Here you will compute, and simply we have directly output, give the output here. That's the simple thing. Okay, I think from these discussions you will got some idea how these productionization models are actually work in real world. When we discuss the case study, there are various lots of case study we have to discuss. Okay, when we discuss the case study, then in details from beginner to up to the end level, productionizations up to the end level, we have seen everything. How to deploy models, how to productionize it, how we'll apply it in a real world, how to find the data, collect the data, how we'll build the model, everything step by step we have seen. Okay, just stay tuned with this channel, and I suggest you actually just share this video those who have actually needed it. And if you have any problem, please comment below. I'll try to make as simple as possible as I can. Okay, so In next video, we have seen there are various kind of technique to productionize models. We have seen it in next video.